Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next topic that we will be taking in digital electronics is going to be counters. Counters is one of the most important concept of digital electronics. We'll be talking about synchronous counters, asynchronous counters. So please try to understand this topic very well. It's a very important topic from the understanding point of view, from the application point of view, from the examination point of view. It is a very important concept. You need to understand this very clearly. The notes are uploaded in the description box of this video. You can download the notes from there. Also, all the summarized diagrams of all the different circuits, counters, flip-flops have been uploaded on my Instagram page as well. So please go and find those diagrams on my Instagram page. The links are given down in the description box. My Instagram ID is Explore Edu to Teach. So please check out, and if you like it, do not forget me to follow me on Instagram as well. So let's begin with counters. So what is a counter basically? A counter is a digital circuit used for counting the pulses. So whatever pulses in the form of clock are applied to a counter, so counter basically counts them as the name suggests. There are two kinds of counters. One is the synchronous counter, other one is the asynchronous counter. So let us try to understand and differentiate between a synchronous and a asynchronous counter. So when I talk about a synchronous counter, all flip-flops are triggered with same clock in case of your synchronous counter. So in case of my synchronous counter, all my flip-flop will have a common clock. Whereas in case of my asynchronous counter, the output of one flip-flop acts as the clock to the other flip-flop. That is very important. As I told you, in case of synchronous counter, my clock is common to all the flip-flop. Whereas in case of asynchronous counter, the output of one flip-flop will be acting as the clock to the other flip-flop. So basically, the clock will be applied to the LSB or the lowest significant bit flip-flop, and all other clocks for all other flip-flop will be the output of the previous flip-flop. So I hope I'm very clear with this. Next, synchronous counters are faster in operation, whereas asynchronous counters are slower in operation. A synchronous counter is also known as a parallel counter, whereas asynchronous counter is a serial counter. So basically a parallel counter is there and hence it is faster in operation. A serial counter is always slower in operation. Next, the propagation delay is lesser in case of my synchronous counter. So if you know the propagation delay, obviously as I told you, a synchronous counter is a parallel counter. It has faster operation. So the propagation delay is definitely going to be lesser. Whereas in case of my asynchronous counter, it's a serial counter. So my operation is going to be slower, but the propagation delay is going to be very higher. In case of my synchronous counter, the examples are ring counter and Johnson counter. Whereas in case of asynchronous counter, the examples are going to be ripple counter. So I hope I'm very clear with this. So a counter is basically a digital circuit which is used for counting the pulses. There can be two counters, the synchronous and the asynchronous. If I have to compare synchronous asynchronous counter, synchronous counters have common clock. Asynchronous counter has clock as the output of the previous flip-flop. In short, if I have to say, synchronous counter are going to be faster. They are parallel counters and obviously the propagation delay is going to be less. Whereas asynchronous counter, it's a slower counter. So basically the propagation delay is going to be high and it's a serial counter. The examples in case of synchronous counters are ring and Johnson, whereas in case of asynchronous it is ripple counter. So this video will be talking about synchronous counter, that is my ring counter over here, and then my twisted ring counter, that's my Johnson counter. The next class will be starting with the asynchronous counter. So if you want to watch this video, please do watch it till the end. Do not forget to like, share, subscribe to this YouTube channel and hit the bell icon so that you get updated for all these future videos which are going to be uploaded on my YouTube channel. So let's start with the ring counter. So if you talk about a ring counter, the logic diagram looks something like this. You have individual D flip-flops in which you have D1, D2, D3. Your outputs given as Q1, Q2, Q3. You have a common clock. I told you in case of synchronous counter, you have a common clock. So if you see D1 flip-flop has clock, D2 flip-flop has individual clock, and D3 flip-flop has clock, that means they have common clocks. It's not that the output of one flip-flop is acting as a clock to the other flip-flop. So here if you see, this is a ring counter which you have Q1 given to D2, Q2 given to D3, and Q3 given to D1. Now a ring counter is a synchronous counter, whereas a ring counter has always same clock to all the flip-flop. The output of one flip-flop is the input to the next flip-flop, and then we have this diagram. So if you just look at the diagram, what I have done is that I have written the inputs D1, D2, D3, and the outputs are Q1, Q2, Q3. So the D1 is basically connected to, if you see, Q3, the D2 is connected to Q1, and the D3 is connected to Q2. So if I just consider the outputs to be initialized to 1, 0, 0, my at clock 1, my D1 will be 0, my D2 will be 1, and D3 will be 0 as per the assigned values over here. If you know in terms of a D flip-flop, whatever is given in the input, that you get in the output. Hence you have D1 0, Q1 0, D1 1, Q1 1, D2 0, Q3 D3 0, and Q3 is 0. Again this is acting as a input to D1, D2, D3. So D1 is connected to Q3, D2 is connected to Q1, and D3 is connected to Q2. So these inputs are again connected to these outputs, that is 0, 0, 1. Again this output is connected to the input. So D1 is equal to Q3, D2 is equal to Q1, and D3 is equal to Q2. So 1, 0, 0. The output is also going to be 1, 0, 0. So if you see over here, within 3 clock, my output is same as the original output at the beginning, and hence I can say the number of output state is equal to the number of flip-flop. If you see in this case, there are 3 flip-flops, and just we have 3 clocks required to bring it back to the original state 1, 0, 0. Hence my number of states is equal to my number of flip-flops. So I hope I am very clear with this. The next thing is the twisted ring counter. So in case of twisted ring counter is also known as a Johnson counter. I have not mentioned over here, but please listen to me. A twisted ring counter is nothing else than a Johnson counter. Now we have a logic diagram present over here in which you have D1, D2, D3, and it is constructed in a way like my ring counter itself. Just the difference is that instead of my Q3 being connected to D1, my Q3 bar is connected. So if you see in case of ring counter, my Q3 is connected to D1, but in case of twisted ring counter, my Q3 bar is connected to D1. So just know the truth table. D1, D2, D3 is the input, and Q1, Q2, Q3 is the output. So you have D1 given as Q3 bar, D2 given as Q1, and D3 given as Q2. So my D1 is 1, 1, 0. My output will be 1, 1, 0. Again this comes as the input to the next clock pulse. So this will keep continuing, and if you see at the 6th clock we have 1, 0, 0, that was the original state of output is retained back, right? So you can conclude that the number of states in case of my twisted ring counter is 2 times of my flip-flop. The number of flip-flops are 3 over here, so there is 6 clock required, so 2 into 3 is 6. Hence I can say a difference between a ring counter and twisted ring counter, that a ring counter, the number of states is equal to the number of flip-flop, whereas in case of twisted ring counter, the number of state is equal to 2 into number of flip-flops. So that is the only thing. I've just explained what is a twisted ring counter over here. So I hope I've tried my best to make you understand about counters, and especially the synchronous counters. It's very important for you to understand this thing. So if you like this video, do not forget to like, share to all the people you know who can get benefited out of it, and do not forget to subscribe to my YouTube channel. Follow me also on Instagram. The links are given down in the description box for all the updates and for all the formula sheets which are regularly updated on my Instagram page as well. Thank you so much guys. God bless you.